am a library assistant here at the Greenville County Library System. Before we begin, we need to say, do not attempt this at home. We're going to be using a microwave today, microwaving things that you really shouldn't microwave. So again, do not attempt this at home, and any part of it that you do attempt, make sure you have adult supervision. Today we're going to go over something called Charles's Law. So Charles's Law explains that as temperature increases, gases tend to expand. We're going to microwave soap and marshmallows, grapes, and even bags. And all of this will show how gases, as they are experiencing an increase in temperature, get excited, they expand, and then you get a really cool show in your microwave. So gather your materials, there's going to be a list below this video, and we'll get started. Alright, so first what we'll do, we'll start with our soap. Ivory soap is made by a neat process where they whip the wax and the soap materials. That whipping process captures air inside of the soap. And if you break it, you can see tiny little air pockets inside of the soap itself. Those air pockets also trap moisture. When we put them in the microwave, that's what's going to make it expand. So when you break the soap, let's see if I can break it. There we go. You'll take about 2 chunks, say about a quarter of the bar, and go ahead and put it in your bowl of water. Whoop! You can see that they're floating. And again, that just explains that this is a product that has trapped air inside of it. So we'll go ahead and break a couple more pieces. Or I'll cut them if you can't break them. Okay. Okay. So we're going to put this in the microwave. You're going to microwave it for about 1 minute. And so what you'll notice is that the soap is starting to expand, and it's going to smell really good in your kitchen too. But the soap is expanding because, again, during that whipping process, air gets trapped in the material. It creates air pockets. The whole point of a microwave is that it makes water evaporate. It makes any material that you put in it, any moisture in that material evaporates in a microwave. And so the evaporating water is making this soap expand. And you can see, remember, all we did was took like 2 little quarter-sized chunks. It's already expanding into a mound about that big. So it's really a neat process. There we go. And careful when you take it out, because of course it will be hot. Of course, you won't be taking this out because you're not doing this at home. It smells really good, but it is hot. Let it cool for just a moment. But when it is cool, you can touch it, and it doesn't feel like you might think. You might think, oh, it's going to feel like whipped cream. It actually is pretty stiff, perhaps almost like tissue paper. It's really crumbly, like I can make it into flakes, but it's still perfectly good soap. Nothing chemically has changed about the item, about the soap itself. It's just expanded because of Charles's Law, that gas inside has increased in temperature and has expanded. All right. What we'll do next is microwave our marshmallows. Your hands are nice and clean, right? Because you've been handling soap. So this is a little different than when you roast a marshmallow over the fire. You're not going to see any burnt, any toasted part of the marshmallow, but it is still heated because, again, there's water trapped in the marshmallow, there's moisture in the marshmallows, and as they get heated, that expands and causes the material itself to expand. A marshmallow you don't need long at all, maybe 15 seconds, depending on the strength of your microwave. again, be careful because they are hot. Whoops! I think I'm gonna knock something over every video. There we go. But be careful if you touch it. But they're squishier, they're hot. Nothing chemically has changed. It's just the physical property of the marshmallows that have expanded. So there's your other little experiment there. Don't forget to eat these. These are good. Don't waste food. Finally, oh, I'm sorry, I cut that out. Next we'll go to our grapes. So this is actually really cool. This has only been recently it's only recently begun to be explained by science. It's long been a trick to take 2 grapes and somehow position them so that they stay together, close together, in the microwave, and microwave them. And you'll see them bounce together, sparks flying in between the grapes. And it's a really neat thing. It creates what's called plasma. Plasma is like a heated, lit gas. It almost looks a little bit like Jell-O that's got a light bulb in it. It's really cool. But in studying this fun little kitchen trick, scientists are starting to better understand how plasma works. And that just has a lot of neat different applications. For our purpose, it's easier. Instead of having 2 grapes close together, we're actually just going to cut the grape. But we're not going to cut it all the way. We're going to cut it just to the edge of the skin, so there's still a piece of skin that attaches the 2 halves of the grape. Right. There will be sparks. Again, do not attempt this at home because you could break your microwave. But it's a neat show. So for our grapes, we're going to microwave them for about 20 seconds. And you'll start to see sparks. It's pretty cool. You hear that fizzing? Of course, that's the water evaporating because of the microwave. Smells like burnt grape. The edge of the grape is a little bit burned. So the reason this has scorch marks and something like the marshmallow or the soap didn't, this began to conduct electricity. So a microwave works, of course, by evaporating things, but it's still electricity. It's still on that electromagnetic spectrum. So electricity started to be conducted between the water molecules. They got excited. That's where you saw the sparks. And that's also why we have scorch marks. Whereas for the soap or the marshmallow, all that happened was that gas expanded and it never had a chance, it never had an outlet to start sparks and create any scorch marks. Finally, we'll take any old chip bag, and you can use a full-size chip bag. A snack size just condenses down to a smaller size. So you can use any size chip bag, big or snack size. I happen to have a snack size on hand. Eat the snack inside. And then we'll pop the chip bag in the microwave. So because you're not doing this at home, I will tell you that I'm just going to microwave it for 5 seconds. I don't need to microwave it for any more. There are definitely going to be a lot of sparks. Again, do not attempt this at home because this really could hurt or break your microwave. But just 5 seconds. Let's see what we got. And it's going to be very hot. This one is legitimately, like, don't touch it hot for a hot minute. Go. And it's really neat because you can see that it's maintained all the text, all the pictures. They've just been shrunk down and they've become kind of bubbly. So we only do for 5 seconds because this could create a fire. Really, please follow that advice. Do not do this for longer than 5 seconds or you might really start a fire. But the sparks in the metal, it's because metal in the bag is a good conductor of electricity. That's where we get the sparks. That's where we get the heat that's in the bag. Because they have nowhere else to go. They're following that line of energy throughout all of the molecules in the metal. But it is pretty cool. Once it's cooled off, it starts to harden. You can see all the bubbles. Even the information on the back of the bag, the dietary information is still visible, still legible. So it's pretty cool. And now this can just be like a fun little tiny person bag for you to eat your chips from. So that's all we have for Will It Microwave. Thank you so much for joining us and have a wonderful day.